Hello and welcome to this GDSLABv2024 tutorial 7.1, how to set up a Calamari based system. There are multiple sections to this video that I'll run through. Firstly, how to connect the device, then using the transducer window and all of its tabs, and finally using the device overview and all of its tabs too. So first, how to connect the device. You will see your device with an orange box around it, and you need to click on that box to open the device overview window. You will see that you will need to press connect and then select the relevant device. It will take a few seconds to load once you've selected the right device, but once it has, you should see values and readings similar to these that appear on the screen right now. These are the available channels. It's worth noting you can see the Calamari device firmware and driver versions at the top right of this window. Okay, now moving on to the transducer window. So the transducer window can be accessed by clicking on the transducer settings icon in the GDSLAB object. I'm going to use my load cell settings as an example. The transducer window has 4 tabs: General, Set Target, Calibration and Settings. So the General tab can be used to apply or remove transducer offset readings, select the number of decimal places, apply minimum and maximum limits for safety, and selecting the real-time graphs during dynamic loading. For the General and Set Target tab, the graph shows a history of the transducer value over time. The 3 buttons on the top right of the graph allow to change the graph duration, save the displayed data and clear the graph. The Set Target tab, if the transducer can be controlled, this tab allows to set manual targets. Selecting hold will stop the axis associated with the transducer, and you can set the targeting rate in the bottom box. The Transducer Calibration tab displays the calibration currently applied to the selected transducer. To change, modify or update the calibration, click on Change/Modify Calibration. Alternatively, it is possible to modify manually the parameters of the calibration. The sensitivity value for the new transducer chip should be calculated from the calibration certificate and entered in the sensitivity window. Setting the wrong parameters could damage permanently the transducer, so please make sure you contact GDS support before adjusting any parameters. If the panel is greyed out, this means that the calibration has been locked by GDS. If you need to change the calibration for the selected transducer, again, please contact us. As you can see, this calibration shows you the minimum system limit, the maximum system limit, the source units, the output units, the full scale and externally powered option, and you also have the sensitivity and hard offset, all measured in kilonewtons. From this window, it is possible to select an alternative calibration or to modify an existing one. In order to recalibrate a transducer or calibrate a new transducer, click on the Calibration Wizard button. Now lastly, we're going to the device overview. Now to access this, it can be opened by clicking on the device image, just like we did in the first thing when we set up the device. In the device overview, you have channels, docking, dynamic stages, log, transducer graph, and advanced tabs, all to use. So to start with the channels tab. The channels tabs list all transducers connected to the Calamari unit, and it displays their current readings and allows the user to apply or remove offsets. Key features include real-time graphs, which enable real-time graphing individual channels by selecting the RT graph checkbox, and graph display live data trends, aiding in monitoring test parameters dynamically. Moving on to the waveforms tab. This can be used to configure waveforms for dynamic cyclic tests. The Calamari unit is pre-configured with a sinusoidal waveform and supports custom waveforms through an upgrade. The features include a default waveform, the sine wave is set to the default waveform, and custom waveforms. So to use custom waveforms, you need to enable the custom waveform checkbox and navigate to the waveform manager tab to select a store waveform. The Calamari box can store up to 8 custom waveforms, each comprising a maximum of 16,000 points. Moving on to the docking tab, this facilitates precise machine positioning before a test. Key functionalities include the extend/retract, and you can move the machine at a constant rate using the extend or retract buttons until the hold button is pressed. The maintain load after docking option stops the machine upon reading the target load, disabling the extend button until the set undock button is pressed. Then you have the dynamic stages tab. This provides controls for configuring dynamic test stages. The lead in, lead out settings. You can define the transition behavior at the start and the end of dynamic trajectory. The lead in duration, which is a time in seconds to reach its full amplitude. The lead out duration, which is time in seconds before the end of the trajectory when amplitude reduces. And the magnitude, which is a percentage of normal amplitude at the start, lead in, and end, lead out. For example, your settings could be amplitude of 1 mm, lead in 10 seconds at 20% magnitude, lead out at 5 seconds, 80% magnitude. Enabling custom lead in, lead out overrides default settings in GDSLAB, so make sure you're aware of that. Then you have the cycle data plan that enables cyclic data saving configurations for dynamic tests. A cycle data plan file specifies intervals for data recording, and each line in the file represents a start to end cycle. For example, to record a data stage from 1 to 9, use 1, 9. Then you have the system log tab. This records all system activities, including requested dynamic trajectories, errors, and fault messages. This log is essential for diagnosing issues, so when contacting GDS support, please provide this log and any relevant entries for efficient troubleshooting. Then you have the transducer graph, and this is the graph tab that provides detailed visualizations of transducer data. The features include, again, real-time graphing for selected transducers via the select channel. Then you have data management options such as save data to file, save images to file, copy images to clipboard, display histograms and FST analysis. And lastly, you have the advanced tab. And this is intended for specialized configurations and troubleshooting under the guidance of GDS engineers. You should note you should not touch this tab unless under direct instruction from a GDS engineer. Anyway, that is the end of the video. Thank you so much for watching. This has been setting up a Calamari device in GDSLAB. Thank you.